In this video, we're continuing with the basics of portfolio risk and return with a look at utility theory and indifference curves, but continuing along similar lines as in the previous video where we introduced different investor profiles: risk averse, risk seeking, risk neutral. This time we're going to quantify things, do a few computations which you may also have to do in the exam. If this is your first encounter with the Let Me Explain YouTube channel, then a very warm welcome. Please consider subscribing or even becoming a supporting member of the channel to get the full advantage of all the content that's on the channel. Okay, let's get cracking. Well, we're going to talk a lot in this video about utility functions. Now, the utility function basically is a mathematical expression which you'll be given in the exam, but will probably be a very specific function that I'm going to show you as well. And what it allows us to do is allows us to rank. So it allows for the ranking of investment choices, investment alternatives with different levels of expected return, but also expected level of risk. So the example of such a function that you'll find in the books and in actually every question that's in the curriculum is as follows. Utility. So the utility of an investment, which is not the same as its expected return. The utility of the investment is how much value it gives to you, the investor, and it's going to be very specific to every investor, is indeed based on the expected level of return. So this is expected return on the investment, or from the investment, or of the investment, right? But then minus something to do with the level of risk that this investment exposes you to. Now, what the book has here is consistently a function that will have a constant of half, 1/2, and the authors do not go into why it's this. It's just an example. And then they consistently use it across all the questions. So don't worry about where this half comes from. There's no justification for it as such. Multiplied by something that they describe as A, and that's multiplied by measure of risk, standard deviation squared, which is, of course, standard deviation squared is the variance of that particular investment. And we'll be plugging numbers into this formula in just a moment. Now, A, very important, is supposed to be a measure of risk aversion. And you can also think of it as the incremental or marginal or additional reward or additional return required by investors to accept an additional unit of risk. Okay, in the sense, how much additional expected return does an investment need to give or produce for it to counterbalance the fact that there is additional risk in it, right, for that additional risk there. Now, you'll be given the A, don't worry about having to make it up in some way, and you'll be given the function, but I would expect it to look like this because this is what they consistently use across all the examples. Now, A is higher for more risk averse investors. So investors who are sort of normal people, they're quite risk averse, which is a classic sort of thing to encounter, sorry, this came out completely wrong. Let me rewrite it. Averse investors. So if investors are risk averse, they would have a higher A, and the more risk averse somebody is, the higher A they've got. You can think of it also as, additional risk causes them to a drop in the utility, so that's sort of the value felt from an investment. If somebody has an A of 0, we would say that they are risk neutral, kind of risk doesn't do anything for them. So that's a risk neutral investor. Now, something you may also get in questions is an A which is less than 0, so negative, and that's what you'll find for risk seeking or risk loving investors who get a kick out of risk. And if A is negative, given the minus sign over here, that second sort of expression in the function becomes a positive thing. So the more risk there is, the more utility they feel. Of course, variance of the investment, the dispersion of returns is the measure of risk chosen here. You'll be given this function in the exam if you need to use it, but if that's the case, probably it will be that specific function. Now, the next thing I want to tell you about are indifference curves. Okay, so we've already said that there's a way to quantify utility, to measure it. Well, indifference curves are basically combinations of risk return pairs which provide or give the same level of utility. Which give the same level of utility, of course, for a specific investor given their specific utility function, especially that A parameter. So the way we draw indifference curves is typically we take the classic sort of graphical expression where on the one hand you're going to have expected return on investment, and here the standard deviation for that specific investment. And the question is, how can you find combinations of return and risk with the same level of utility? Well, you'd have to plug them into the function, and maybe a risk-averse investor could have an indifference curve like this. So all the points on it, each one being a distinct combination of risk and return, give the investor the same level of utility. And as you can see, the slope of the function becomes increasingly steep here, because in order to convince the investor to take on additional unit of risk, the additional reward, the additional compensation in the form of return has to be accordingly higher. And that comes from the fact that we've got a square over there to cause that steepness to go up. Now, that's one indifference curve. Another indifference curve could be something like this or something like this. But as we get lower, as we go lower down over here, we get less utility. So these are all indifference curves for the same investor, but they've got different levels of utility. Here, that most sort of the highest, and to the left, that highest indifference curve gives the investor the highest level of utility. Everything is going to be lower, less utility. And one more thing that I want to graphically depict before we start solving numerical questions is how you would portray or map out indifference curves, but now for investors, not for the same investor, but for investors with different levels of A being the measure of risk aversion. Okay. So I'm going to go along with a graphical depiction that you can also find in the curriculum. And I mean, when I took this exam many years ago, it was already there, so it's a classic, so to speak. So once again, you're going to have expected return on the vertical axis, standard deviation over here on the horizontal axis, so the measure of risk or dispersion. And let's say this is going to be some classic sort of indifference curve for an investor who's relatively risk averse. So this is somebody who's characterized by high risk aversion. For them, the A parameter is going to be pretty high. Well, this is also somebody who's risk averse, but more moderate in that respect. So this is moderate risk aversion. For them, for this second investor, the moderate one, they don't require so much additional reward in terms of return for taking on that additional risk. Whereas here, with the first one, they expect to be compensated a lot more to take on the additional risk. That's what we're talking about here, right? Now, this is yet another risk-averse investor, but even less so. So this is low risk aversion, which it's not the same as negative or zero. Now, zero would be like this. This is somebody who has an A parameter equal to zero. So all the ones in blue over there have A higher than zero. It's just a question of how much. If somebody has a risk aversion of a parameter of zero, it means they're risk neutral, so they're indifferent to risk. And you may remember that we said in the previous video that a risk neutral investor is somebody for whom the only concern is actually expected return. Risk is completely irrelevant or neutral, as the name suggests. So this is risk neutral. They don't get any drop in utility from the fact that they have to bear additional risk, nor do they feel a kick out of risk. They're sort of completely cold when it comes to risk. Obviously, if you make the A parameter here in this function zero, in this equation zero, obviously the whole term to the right of the negative sign of the minus becomes zero as well, leaving us just with expected return. And then somebody who is risk-seeking or risk-loving is actually going to have an A that's less than zero. Okay, that's the graphical way to think about it. It should help those of you who have a sort of more graphical memory or graphical mind. Definitely speaks to me better than the function on its own. Now, I've got a few questions here that I've prepared, taking into account what's in your books and how those questions in the books are sort of phrased and framed. And we'll just go through 4 questions, which are all of them numerical. The computations are really simple, so I won't be showing you my calculator. I mean, you won't have to do as many questions as this on the same topic. I just wanted to explore it sort of to quite a large extent, so to speak, quite deeply, with the same set of questions. So the same sort of scenario. The following characteristics are available for 4 investment portfolios, and for each one you've got their expected return and standard deviation, expected standard deviation measured in percent. And question 1, if an investor's utility function is expressed as you can see, same expression, well, hopefully you can see that, as we had before, and the measure of risk aversion, that's the A parameter, is 2, the investor is most likely to choose, well, which one? So this becomes a simple plug the numbers in and see what comes out and choose the highest result, or the outcome with the highest result, the highest utility. So for portfolio 1, I mean, in these questions, go with calculate, the outcomes or the results for those portfolios which are at least part of the question. Don't do too much work. Don't do it for all 4 portfolios necessarily. So utility of the first portfolio would be its expected return, 13%. Now here, be careful in these ones. Express this as decimal. Don't just go 13% minus and work with this. That's asking to get this wrong. I mean, you'll get the units wrong, etc. So 0.13 minus half times 2, which is convenient because it cancels each other out and becomes 1, multiplied by the standard deviation squared, so that's 0.1 to the power of 2. Quickly do this on the calculator. 0.13 minus, I'm ignoring this half times 2 because it gives 1, 0.1 to the power of 2. Okay, that equals 0.12. Now don't worry about the units, those are not relevant right now. For the second one, U2, utility 2, right, 0.15 minus, same story, half times 2, which simplifies to 1, and multiplied by 0.22 squared. Okay, let's see. That gives 0.1016, and for the fourth portfolio here, that's the one with the highest level of risk, so I strongly doubt that this is going to be the one, especially as this investor is quite risk averse. They've got a very, very distinctly positive A parameter, but let's just quickly do it for the sake of comprehensively solving this problem and not guessing, writing out the data like this. Let's have a look. 0.14 minus 0.35 squared equals, right, I get 0.0175, so that's definitely the lowest. So if I was to optimize here as an investor with this utility function, we would go with answer A, which is portfolio 1. By the way, it's very difficult to appreciate what somebody's utility function is. I mean, it's a very nice theoretical construct, but in reality, you never know. It's very difficult to measure somebody's utility function and find an expression for it. Okay. Now, question 2. If an investor's utility function is expressed in the same way, but we've got a changed risk aversion value, so the A parameter now becomes 0.5 instead of the previous 2. So this investor is still risk averse, but definitely less so more moderate or low risk aversion, closer to 0 for sure. Let's see what that gives. So first portfolio, we know its expected return is 13%. We now have minus 1 over 2 times 1 over 2 because of the half over here, so that's obviously 0.5 squared, and multiply that by the standard deviation, which was 10% squared. Let me do this. 0.13 minus 0.5 squared times 0.1 squared. Okay, the answer I get is 0.1275. You see, because this investor is definitely less risk averse, they get a bit more utility out of the first portfolio than the more risk averse investor, for whom that additional risk was causing a bit more pain, so to speak. Now, for the second portfolio, I guess that difference will still be there, but it's going to be even bigger because of the higher level of risk involved. So U2, utility 2, I'm just drawing the numbers from over here, that's 15% for the expected return, minus 1 over 2 times 1 over 2 times, and now we take this standard deviation squared for the second portfolio. Let's see. Okay, 0.1375, yeah, so definitely higher utility than here. And actually, more utility than for the first one. That's even better for them, right? They're not, and that's caused by the non-linear nature of the indifference curve, the trade-off between risk and return. Let's just check the utility of the third portfolio. Now, we haven't dealt with this one before, so we don't have the data yet anywhere. 16% and 27% for expected return and standard deviation, respectively. So 0.16 minus half times half part times, sorry, I already forgot what it was, 27% for expected standard deviation. Right. Good. What's this? So 0.16 minus 0.5 squared times 0.27 squared equals 0.1418. Brilliant. That's the highest utility we see over here. So that's going to be our choice. The answer is C, and it goes to portfolio 3. And by the way, I did solve this for portfolio 4 as well. But for portfolio 4, you wouldn't get more utility because you've got less expected return and a higher level of risk. Now, somebody who's risk averse, given their utility function, tries to maximize the utility, taking into account their own individual trade-off between risk and return. They would definitely not choose portfolio 4. You would never choose it because it just produces less expected return and more risk. Well, you would choose it if you've got a specific attitude to risk that we'll get to in just a moment's time. Now, for question 3, which of the portfolios is most likely to be chosen by a risk-neutral investor? This is somebody who has an A equal to 0 and don't expect to be told that. You'll just have to know. And this is going to be somebody who just tries to maximize, therefore, expected return, and chooses the portfolio with the highest expected return, which is portfolio 3 over here, with a 16% expected return. It doesn't matter. For them, standard deviation is not going to be important. So portfolio 3, this one, the answer is therefore B. And now for question 4, this is somebody who has the same utility sort of function expression, but they've got a completely new A parameter, A equals -2, and we associate this with the risk-seeking or risk-loving investor who gets additional utility from taking more risk, like a gamble. Makes them get the thrill of that. That gives them positive emotions, right, which can be quantified here. So let's try to do this. The utility of portfolio 2, its expected return was 15 to start with percent, minus half times -2, right? So this will become a -1, which in combination with the minus, which is already in front, will give a +1, times 0.22. That was let me just check again, that was indeed, yes, the standard deviation for portfolio 2's returns. Let's see, 0.15 minus half times 2 negative, okay, which is actually +1, times 0.22 squared equals, right, I get a result which is 0.1984. That's the utility, and as you can see, for the first time we have a utility which is higher than the expected return alone, because in all the other ones, if you started with an expected return of something, whatever it was, you would always end up with a utility that was at least slightly lower because of the risk having a negative impact. Here it's different. Now for portfolio 3, let's see what we get. 16 and 27 is the combination. So 0.16 minus half times the same minus 2 times 0.27 squared. Right, so effectively I've got 0.16. I'm just going to simplify this to say it's, well, together with this it's plus 1. So plus 0.27 squared. Okay. 0.2329. And the final one, 14% and 35%. So, you know, this investment is not offering as much as the others in terms of expected return, but it does kick a punch in terms of risk. Definitely higher than the others. So 0.35 squared. Let's have a look. 14 or 0.14 plus 0.35 squared. Yeah, 0.2625. That's the highest utility of all three. So the answer would be C, portfolio 4. Very characteristic, you know, for a risk-seeking investor. They get the thrill of the uncertainty of the risk involved, and that may overshadow the return. Okay, if you were doing these computations and you couldn't get the results as quickly, or you got some different results, it may be because your calculator is not set to AOS mode, algebraic operating system mode. Make sure to format it to that mode. You'll find videos on it on the channel on how to format your Texas Instruments calculator. Other than that, see you in the next video.